Hello and welcome to our channel. Many people ask, how accurate is the OPS 243 radar sensor? They need to prove to local municipalities, police, or others that the speeds reported from the sensor are correct. In this video, we're going to show how easy it is to confirm the speed accuracy of your radar sensor using a tuning fork as described in the AN26 application note. There are several options for using a tuning fork. For vehicle traffic and radar speed signs, there are certified tuning forks which are designed specifically for a set speed. These tuning forks are labeled with the speed and frequency of the operation they were designed for. Our OPS 243 radar sensors operate at 24 GHz or K-band, as shown on the tuning fork. Make sure you use a tuning fork designed for K-band when testing the OPS 243 radar sensors. Alternatively, you can take a standard tuning fork, which is labeled with its oscillating frequency like this one. When using one of these tuning forks, you'll need to convert the frequency to the appropriate speed. We'll show how to do that later in the video. First, you want to configure your sensor for the tuning fork used. If you use a tuning fork for a set speed, change the output to the proper units. In this case, we're using a 35 miles per hour tuning fork, and we'll change the sensor output to miles per hour with the US API command. Next, you might want to improve the speed resolution. If you do the !!! API command, you'll see the current settings in the speed resolution. In our case, it is 0.14 miles per hour. Normally for traffic monitoring, we use 20 case samples per second, which is the S2 API command. We'll then improve the speed resolution by increasing the FFT size to 4096 with the X4 command. Issuing the !!! command again shows the speed resolution is now 0.07 miles per hour. We're now ready to test with the tuning fork. To test for speed accuracy, simply hit the tuning fork on the side of a solid object and hold it over the antenna of the OPS 243, around 4 to 5 centimeters or 1 to 2 inches away. You should see the speed of the tuning fork on the terminal window. It averages 35.3 miles per hour, or within 0.9% of the tuning fork listed speed. The math behind the speed and tuning fork frequency is relatively straightforward. The main equation is shown with the speed equal to the delta frequency detected by the sensor times the speed of light divided by 2 and the frequency of the sensor operation. For the OPS 243 radar sensors, the frequency of operation is 24.125 GHz. The speed of light divided by the frequency of operation is also known as the wavelength, which at 24.125 GHz is 12.4 millimeters. We can use this equation to create a table of common frequencies and speeds for the OPS 243 radar sensors. In addition to this, an interesting API feature of the OPS 243 radar sensor is the ability to output the frequency detected. You can do that with the UH command.